Alright, in this problem we've got two squares. We've got A, B, C, D, and we've got B, E, F, G. Okay, so a smaller one and a bigger one. And we're told that the shaded area here is 10 square units. Okay, so I'm just going to write 10. So the whole region is 10 square units. And we're supposed to find the area of the smaller square, A, B, C, D. Alright, well, again, this one doesn't seem like it has enough information. But what I'm going to do, I'm just going to label these sides. So I know this is a square, so let's just call the side length of the smaller square A. Okay, and let's call the side length of the larger square B. Okay, and then, so this is A, and this is A, and actually we could find the distance here, this little short segment here, GC, that would be the distance B minus A. So this is B minus A. So what I'm going to do is come up with an expression for the area of this shaded region and then set it equal to 10. But I'm going to find the expression in terms of the side lengths A and B. Alright, so let's do that. I'm going to scroll down. Let's see, because it's kind of a long one. Alright, so what I could do to find the area of the shaded region is just to take the sum of the areas of the two squares. Okay, and that's just going to be A squared plus B squared. And then I can subtract out these triangles. So like here I have a triangle that's a right triangle and with a base of A and a height of A. So I can subtract out that triangle. That's minus 1/2 A times A, which is A squared, right? Base times height. And then, let's see, we've got this triangle here. We could take the base to be B and the height to be B minus A. So let's subtract that. So 1/2 B times B minus A. Okay. And then we could just take this whole triangle here, alright, this whole thing. Whoops, and I think I've got something labeled wrong here, because this isn't A, is it? This is B, alright, that's the side length of the larger triangle. So what's that area? We could take the base to be A plus B and the height to be B, right? It's still a right triangle. So let's subtract 1/2 A plus B times B. Alright, and that's going to be equal to 10. Alright, all I've done is taken the sum of the two squares and subtract out the triangles that aren't shaded. And that should give us the shaded area. So, alright, let's simplify this a bit. I'm going to scroll down again here. Alright, A squared plus B squared. Here we have, I'm just going to leave this 1/2 A squared. This one I'm going to multiply through. So I'm going to take the 1/2 B, and it's actually negative 1/2 B, and I'm just going to distribute it inside the parentheses. Okay, so we'd have negative 1/2 B squared, and then a negative times a negative is a positive, so we'd have a plus 1/2 AB. Alright, and then I'm going to do the same thing here. I could actually write this, I could write the B over here and get rid of this one. And then distribute. Okay. So this is going to be minus 1/2 AB. And then the next term is going to be minus 1/2 B squared. Okay, and that's still equal to 10. Alright, let's combine like terms. Now I'm seeing here a positive 1/2 AB and a negative 1/2 AB, so that's just 0. Here I'm seeing a negative 1/2 B squared and a negative 1/2 B squared, so that's just negative B squared. And let's see, what else can I combine? I guess I have this 1/2 A squared. Well, okay, so if I combine these three terms, I get 1b squared minus a half b squared minus a half b squared. So those are just going to be 0. Okay. So all I have left is a squared minus 1/2 a squared. So that's just 1/2 a squared, and that's equal to 10. And so that means that a squared is equal to 20. Okay? Which is actually what we want to find. We want to find the area of this smaller square, ABCD. And the area of that is a squared. So that's our answer, is 20 square units. Okay? That's kind of an interesting result too, really, because it really doesn't matter how big B is. If we connect the diagonal, or well, connect the far corners, I guess, of the squares, and then connect this upper corner to the far corners, and if that's 10, then we can find the area of the small square. So it doesn't matter whether it's, you know, this big, or if we've got some small square and a really big square. If we connect the far corners and create this kind of, well, it's kind of a tough one because it's going to be this kind of skinny, it's hard even for me to draw my line straight. If this is 10, then then the area of this is 20, no matter how big B is. Or the same way if they happen to be the same size. Say we have two squares like this. Okay, let's say those are the same size. Then essentially, you know, our triangle looks like this. So if this is 10, then the area of the square is 20. So anyway, the answer is 20 square units.